Hello everyone and welcome to my YouTube video. Today I'll be doing a CAPE video on trigonometry. So first, before we even get into CAPE trigonometry, we should first understand the fundamentals. Because if you don't understand the foundation, well, it's going to be kind of hard to understand how to actually do the subject. So we'll just start with the fundamentals. So here's something you should remember. Sorry, I voice cracked. Here's something you should remember from um, math and math. You should remember so, ka, toa. If you don't remember, we're just going to go over it shortly. If you already know this, you can skip ahead. I've added timestamps in the description, and you can just use that to skip through the video and find the points that you want. But for those of you who want to start from the very beginning and get the foundation in, this is for you. So let's say we want to take sine of the angle. So in this case, it's sine of theta. So this is the angle theta here. And if we want to take the sine of that, then we know from SOHCAHTOA that sine is equal to opposite over hypotenuse. So look at the triangle. This is a right angle triangle, of course. What is opposite to the angle? Well, what's just on the opposite side of it? This is the opposite. In this case, if you can't see from this drawing, it's b. So we're going to say that it's equal to b over. Now, what's the hypotenuse? Remember, the hypotenuse is always going to be the one that the right angle points towards. So that's a free one to know all the time. The hypotenuse points towards the right angle. And so in this case, the hypotenuse is C. And now let's say for cos, let's say we wanted to take the cosine of the angle. So we'll have cos theta is equal to, so now cos is equal to ka, so that's adjacent, over hypotenuse. So the adjacent is right next to the angle right here on the side of it. So if we take cosine of this angle theta, we'll have A over the hypotenuse, which we know is C. And the last one now, which doesn't actually use the hypotenuse, is tan theta. Now for tan theta, we know that this is going to be equal to the opposite over the adjacent. And so the opposite of the angle, which we found earlier, was B. So we'll say that's equal to B over the adjacent, which we just found again, which is A. So it's B over A. And that's tan theta. So these are your three sine, cosine, and tangent. These are the three things you should have known already. And with that said, we'll be going into things that you should know from CAPE or ADMATH. Let us start. So reciprocal identities. These are the very start of CAPE. Without these, you won't really be able to do anything in trigonometry because you're going to have to understand these fundamentally and conceptually. So let's start. Now look at the third letter of each of these things. What do you notice about them? So we just went over sine, cosine, and tangent. Now if you look at the third letter of each of these, you'll realize that it's actually just a giveaway as to what they are. Now in this case, cosec, if we look at the third letter, well, what begins with S? Sine does. So using the third letter, cosec is equal to 1 over sine theta. And by that knowledge, we also know that sec theta is equal to 1 over cos theta. And of course, the easy one, which is cot theta, is going to be equal to 1 over tan theta. And these are the reciprocal identities that are the foundation of CAPE. Hopefully you're understanding so far. I mean, there's not much to understand, you just kind of have to swat these things. These things, you have to know them. So take a moment, pause the video, and ensure that you remember them, okay? So cosec is equal to 1 over sine, sec is equal to 1 over cos, and cot is equal to 1 over tan. Okay? So just keep looking at the third letter and remembering, because with these you'll be able to solve questions with a very good understanding of them. So let's move on. Now there's one other thing that you should know, and is tan theta. Now we know tan is also equal to opposite over adjacent, right? But what is also equal to is sine theta over cos theta. And that's just something to take into consideration because it's also used a lot. I won't be showing any proofs for these things because more than likely you won't be asked to prove it, But if you really want to learn how to do that, you can always Google it on your own. But for the sake of simplicity, I won't be showing any proofs, so you just have to know that tan theta is equal to sine theta over cos theta. Now that that's done, we've gotten over the fundamental reciprocal identities and tan theta. Now, here's something else that we use in CAPE, and this is actually how we solve questions. Now, this is a fundamental identity. This is where fundamental really gets its word. Without this, we won't be able to solve so many different proof questions. And it is sine squared theta plus cos squared theta is equal to 1. So take a moment, just think about it. Sine squared theta plus cos squared theta equals 1. SWOT it, remember it, do whatever you have to do, put it on a flashcard, get that in your head. So let's say we wanted to transpose for sine theta. If we wanted to make sine squared theta the subject, meaning we had it in an equation, and we wanted to break it down in terms of cos, well, sine squared theta, if we just take the cos to the other side, it's going to be equal to 1 minus cos squared theta. We just transposed, simple as that. And same thing, you could do it the same thing for sine theta would be equal to 1 minus, sorry, cos squared theta would be equal to 1 minus sine squared theta. And yeah, you can do that and it's perfectly fine. And that's perfect. That's perfect already. That's pretty good. That's a fundamental identity that you need to know in order to solve questions. So let's say we had sine squared theta plus cos squared theta. I will say it's equal to 1. And we divided each term by sine squared theta. What would this give us? So sine squared theta over sine squared theta, that cancels out. We know that's equal to 1. Cos squared theta over sine squared theta, well, let's look at it this way. If we know that tan theta equals sine over cos, and we know that 1 over tan theta equals cot theta, then what is 1 over tan theta in terms of sine over cos? Well, we'll say cot theta is equal to, we just flip the sine over cos, we'll say it's equal to cos over sine, right? And that's all you have to think about. So in this case, cos squared theta over sine squared theta, well, if we just squared all of this, it would just be equal to cot squared theta. So this is going to be 1 plus cot squared theta equals, now what is 1 over sine theta? You should have remembered this from the very first part of the video with trigonometric identities, well, the reciprocal ones, and well, 1 over sine is just cosec. So if it's 1 over sine squared theta, it's going to be cosec squared theta. Right. And this is another identity that you need to get familiar with, but you could always derive it if you really had to. But if you really want to save time, just remember it, okay? And now we divided the last time by sine. But what if we wanted to divide by cos? So if we divided everything, each term, by cos squared theta, well, what would we have? Well, we know that sine over cos is equal to tan, so we'll say that's tan squared theta plus cos over cos is just 1 is equal to 1 over cos squared theta. Now, we know that 1 over cos theta is equal to sec theta, so 1 over cos squared theta is just going to be equal to sec squared theta. And this is another identity. Now at this point we've already gone through all the identities that you really need to know. Just take a moment, you can scroll back up in the video and just try to internalize it a bit, okay? So now we're going to actually try to solve some questions. We're going to go through around 3 questions, and then I'm going to take us to some past papers. And in the next video we'll go over how to solve trigonometric equations. And we'll go through the different forms, you don't have to worry. I'll be going through the entire syllabus and we'll just go from there. So if we have this is 1, number 1. 1 minus cos squared theta over sine theta is equal to sine theta. So we want to prove, right? We want to prove that this is the case. So I'll actually just bring this down a little bit. Oops. Right now, it's a bit, and I'll just write proving identities here. But in the meantime, you can have a go at it yourself. Think about what to do. Please pause the video. I'm not giving you any questions that you can't do. So anything I'm giving you right now, you'd have had to learn it from within the past, what, 10 minutes of this video. So yeah. So 1 minus cos squared theta, what is that equal to? So we see there that is cos squared theta. So immediately, I'm going to think of sine squared theta plus cos squared theta equals 1. So I'm just going to write that down, right? So I'm going to write down sine squared theta plus cos squared theta equals 1. Now, what is 1 minus cos squared theta? So if we brought cos squared theta over to the other side to make it negative, we'd see that sine squared theta is equal to 1 minus cos squared theta. And in this case, we can just remove where we have here, we can remove this 1 minus cos squared theta and instead add sine squared theta. So now we'll be getting sine squared theta over sine theta should be equal to sine theta. And you know that if you have something squared, so you see you have x squared over x, it's just equal to x. The square cancels out, and the bottom one goes away. So in this case, sine squared theta over sine theta, well, that's just going to be equal to sine theta, right? So say sine theta is equal to sine theta, therefore true. So we just proved a trigonometric identity. We just solved our very first question, and yeah, pretty good. Now we're going to be continuing a little bit more. So for our next question, we'll be proving the identity 1 plus cos x over 1 plus sec x. Oops. I put yes, I think I need to, yeah, is equal to cos x. So here's a tip. Immediately, whenever you're doing these kind of questions and you see anything that deals with sec, cosec, or cot, or even tan, just immediately replace them in terms of cos and sine. Immediately. Because it's going to make it so much easier for you because you know how to work with these. So removing that, we'll have 1 plus cos x over 1 plus, now remember sec is just 1 over cos, so 1 over cos x should be equal to cos x. So if we see the denominator is this, right, we can actually work the denominator out. So here we go. So to work out the denominator, we can start on the left hand side. Well, sorry, not left hand side. We started on the left hand side in general. It's something I forgot to mention, but you should always start on the side that has more information. So we'll have 1 plus 1 over cos x over cos x. And it's just 1 over 1. So 1 into cos x goes cos x times. So 1 times cos x is just cos x. Plus cos x is a cos x goes, it goes 1 time. So we just multiply 1 by 1. So now the denominator with this addition sign can be replaced by this. Cos x plus 1 over cos x. So we'll have 1 plus cos x over cos x plus 1 over cos x. Now, this is just the same thing as saying 1 plus cos x divided by cos x plus 1 over cos x. So I'll rewrite it in this form. So we'll see, rewriting, we'll have 1 plus cos x divided by cos x plus 1 over cos x. Now you know that dividing by something is the same thing as what? What is it? The same thing as it's the same thing as multiplying by the reciprocal. So we'll say that 1 plus cos x times the reciprocal of this is just bring the what's on the bottom to the top and what's on the top to the bottom. So it's going to be times cos x over cos x plus 1. And seeing this, we can cancel it out, and we're left with cos x on this side. So we'll say cos x is just going to be equal to cos x. Therefore, the left-hand side is equal to the right-hand side. And that is proved. And that's great. So let's move into a question that's a tad bit more difficult, one that will use a little bit more of our knowledge, and that's great. Right after this question, we'll be jumping into past papers, and the lesson will conclude there, and you'd have already understood the basics and foundations of trigonometry. So we'll have 1 over 1 plus cos theta plus 1 over 1 minus cos theta equals to 2 cosec squared theta. Now, how do we do this? So which side has more information? So this is the left-hand side, and this is the right-hand side. So obviously the left-hand side has a whole lot more information to work with, right? So let's add these two actually. So if we find the lowest common multiple, right? Well, because the denominators are not the same, we'll multiply both denominators, right? So 1 plus cos theta and 1 minus cos theta. If you don't understand how this is, please look up uh I guess you'd say multiplying adding fractions where the denominators are not the same and cannot be the same without multiplying them. So yeah, you should just check that out if you don't understand this already, but if not, you should be following pretty well. And yeah, so 1 plus cos theta, so we know that this is going to be equal to, so 1 plus cos theta into 1 plus cos theta goes 1, so it's going to be 1 times 1 minus cos theta plus, and then this into this, I said this into this, but you didn't see, but this into this goes 1 time, so plus 1 plus cos theta. I'll put these into brackets so you'll see what I'm doing more. Okay, and now we'll kind of fix it a little bit better. Okay, so this is also equal to, well, actually I'll remove the brackets now so we can actually evaluate it. So 1 plus 1 is 2. You should know this from, I don't know, like from your 1 or so. I don't know how old children learn this. And then minus cos theta plus cos theta is just going to be 0. So it's just 2. So on the numerator we have 2 over 1 plus cos theta and 1 minus cos theta. So that implies, so if you notice something about this, right, I want you to take a second and just look at this. Or actually, no, we'll evaluate it. So let's evaluate the denominator now. So we do this by expanding. So 1 times 1 is 1, minus cos theta times 1 is minus cos theta, plus cos theta, because we're now doing this one, plus cos theta, minus cos squared theta. So these two cancels out, and we'll have 2 over 1 minus cos squared theta. Now, if you remember from the fundamental identity that I've been talking about this whole video, cos squared theta plus sine squared theta equals 1, then 1 minus cos squared theta is going to just be equal to sine squared theta. So that means we can replace this denominator, by sine squared theta. So we'll have 2 over sine squared theta. And well, what is 1 over sine squared theta? So this is the same thing as saying 2 over 1 times 1 over sine squared theta. And we know that 1 over sine squared theta is what? It's cosec theta, right? So this is equal to cosec squared theta. So in the end, we'll just have is equal to 2 cosec squared theta. And that's actually what the question had asked us to prove. Remember? Remember? Please always be looking up. I think I lost the question. Did I lose it? Oh, it's right here. Yeah. So they asked us to prove that's equal to 2 cosec squared theta. And that's what we were able to do. So it's equal to the right hand side. Therefore, true. And that's pretty good. So you just solved 3 questions. Hopefully you are kind of getting the gist of it. And now we're going to be moving more into past paper questions. So I have 2 past paper questions here that I had just worked and thought they would be good to show you. And they deal with proving identities. So you'll see how it actually happens in the exam. So this is going to be the past paper section where we actually practice this, right? So we want to prove that tan theta times sine theta over 1 minus cos theta is equal to 1 plus 1 over cos theta. Now, what did I say earlier? Whenever you see things that can be changed out, 9 chances out of 10, you can just change it out, okay? So 9 chances out of 10, just change this out. So we have tan theta, and we know that tan theta is equal to sine over cos. So say sine theta over cos theta times sine theta, and that's going to be equal to over 1 minus cos theta. Sorry, so that's equal to 1, sorry, not equal to, it's over 1 minus cos theta. So how do we do this now? Well, let's just multiply the numerator so far, okay? So the numerator will be multiplied to give us sine squared theta over cos squared theta. No, not cos squared theta, sorry, over cos theta. And well, this is just being divided by 1 minus cos theta. Sometimes writing it with the division sign makes it a little bit easier for you to understand. So I'd always recommend, if you're not getting a question, just try to write it out with the division sign, okay? Okay, great. So what are we going to do now? So if we're dividing, well, that means that we can also just multiply it by the reciprocal. So we'll have sine squared theta over cos squared theta times 1 over 1 minus cos theta. Okay? So I'll give you a second to catch up, follow what we're doing. We just multiplied the numerator. We substituted tan as sine theta over cos theta because that's something we learned in like the first minute of the video. And then we multiplied the numerator and we're just dividing by the denominator. We haven't done anything extensive yet. That's all we're doing, okay? And now what can we do? Well, we know that sine squared theta is the same thing as what? So we have sine squared theta plus cos squared theta equals 1. So that means sine squared theta is equal to 1 minus cos squared theta. So in place of sine squared theta here, we want as much information as we can get because we're going to want to try to solve this question, right? And oh my gosh, I'm so sorry. I have cos squared theta here just because so many squared stuff. My apologies. So we know it's equal to 1 minus cos squared theta. So instead of sine squared theta, we'll write 1 minus cos squared theta over cos theta. It should be multiplied by 1 over 1 minus cos theta. Now, what is something you notice about this? Well, it's probably not the most intuitive thing, but 1 is the same thing as 1 squared. And if you have a squared minus b squared, that's the same thing as a plus b times a minus b. So it's no different for this. 1 squared minus cos squared theta is the same thing as saying 1 minus cos theta times 1 plus cos theta over cos theta. And then we're multiplying this by 1 over 1 minus cos theta. And since we're multiplying this, we can cancel these two things out. So what will we be left back with? We'll have 1 plus cos theta over cos theta. And this should be equal to 1 plus 1 over cos theta. So, well, oops, I'm spoiling the next question. But what you can do is you can break it up because of this addition. You have 1 over cos theta plus cos theta over cos theta and this will be 1, and 1 over cos theta is just sec theta, so it's going to be equal to sec theta plus 1. But they don't even ask for that, they just want us to have this. So it's going to be equal to 1 over cos theta plus 1. And that's simply the answer. So hopefully you're getting it. This is a 2020, was it 2022? Yeah, it was 2022, so it wasn't a very hard question. So hopefully you're getting that one so far. Now let's move on to something else. So we have sec squared theta is equal to cosec theta over cosec theta minus sine theta. Now, that's a mouthful. We have a lot of cosec, sine, sec, all that. We have a lot of weird business going on here, and it's kind of weird, right? So let's try to simplify it, right? So in doing this, what I'm going to do, actually I'm going to use another color. We've used enough yellow for today. How about green? Yeah. So I'm just going to rewrite the question. So it's always good to rewrite a question sometimes if you want some more space. Cosec theta over cosec theta minus sine theta. So we're trying to prove that's equal to sec squared theta. Now, which side, the left-hand side or the right-hand side, which of these has more information? Well, obviously the left-hand side, because it's filled with a bunch of stuff, right? So we're going to go through the left-hand side a little bit more. So we have cosec theta. So we'll say cosec is equal to what? So we look at the third letter in the word. So we'll say it's equal to 1 over sine theta. And that is going to be divided by, what's cosec again? Well, it's just going to be divided by, wait, hold on, let me just see, yeah, it's going to be divided by 1 over sine theta minus sine theta. And before we actually divide these, let's just actually work this subtraction out. So 1 over sine theta minus sine theta over sine theta. This will be 1 minus sine squared theta, yeah. So it's going to be 1 over sine theta divided by 1 minus sine squared theta over sine theta. Now 1 minus sine squared theta, I've been speaking about this one identity this whole video because I hope that you're finally getting to remember it. Equal to 1. If we brought the sine theta over to the next side, we have cos squared theta is equal to 1 minus sine squared theta. So where we have 1 minus sine squared theta, we can just replace it with cos squared theta. So we'll have 1 over sine theta divided by cos squared theta over sine theta. And what did I say about dividing? Well, it's the same thing as multiplying by the reciprocal of this. So instead we could have 1 over sine theta times, when we flip this around, we get sine theta over cos squared theta. And we can simply cancel these things out, and we'll have 1 over cos squared theta, and this should be equal to the right hand side, sorry, and the right hand side is sec squared theta. It should be equal to sec squared theta. And we know that since this is the third letter, it's going to be equal to sec squared theta is equal to sec squared theta. Because we know that 1 over cos theta is equal to sec theta. So 1 over cos squared theta is equal to sec squared theta, and therefore we have just proved it. And this was on 2016. So overall, trigonometry is a pretty decent topic. Trigonometry itself is, in my opinion, is going to be the easiest part of Module 2. I'll also be doing videos covering coordinate geometry and vectors. And yeah, but for the most part, this is all you really have to know. Hopefully you're understanding so far. And yeah, if you're not understanding, please just rewind the video, and you can always look in your textbook or something or ask your teacher, and you could leave a comment if you're unsure of something. I'll be going through the whole syllabus as I said before. My next video will be teaching you the quadrant system, because you have to understand the quadrant system in order to understand how to solve trigonometric equations. And with that said, the video will now be ended. I hope you enjoyed the video. If you did, um, that's great, I guess. But yeah, thank you for watching.